Hi, my name is Maria Jose Lor. I present a project to you, sharing capacitive loads with eFuse. Definition. The eFuse protection devices are used for limiting the system load current in the event of overload or short circuit. Many applications employ a semiconductor eFuse at the power input stage of the system between the main power input connector and DC converters or power regulators. The system utilizing eFuse protection device at the power input stage may represent inductive, resistive, capacitive, or mixed types of loads. Characteristics. One of the common load characteristics for various systems is large capacitive load, typical starting from 1 millifarads all the way to few hundred millifarads. Challenge. The challenge represents be such load to an overcurrent protection system is large in-rush current due to the excessive capacitance, which will cause the device to shut down during startup. Application. Typical way of handling the device startup into a large capacitive load with eFuse is to control the output slew rate by slowing it down. The figure 1 shows the typical arrangement of the eFuse before the system, which is protected from overcurrent and utilizing a large input capacitance designated as code on the eFuse side. Typical application. eFuse protecting a system with large input capacitance from overcurrent. Step 1. In order to avoid the turn off during a startup, the slew rate can be slowed down, usually by the means of adding capacitor to the DVDT pin of the given eFuse. Alternatively, an auto-retrieve feature of the eFuse can be utilized, which allows the in-rush current in the limited amount to flow through the internal FET during the startup while charging the output capacitance code. Step 2. When the eFuse with auto-retrieve feature is selected, the output voltage slew rate limitation does not need to be set. The user will just set a desired current limit level and configure the device with minimum slew rate, which I usually don't believe DVDT pin unconnected. Pros and cons. Pros. Allows a restart after fault events cleared. It allows a large output capacitance to be pre-carried to the target input voltage at startup. The internal temperature sensor does not allow the FET to overheat. The input current can also be set to any desired value during a start phase. Cons. The current on and off cycles are much denser at the beginning once the eFuse has just been turned on. Potential for the internal FET is very large, thus resulting in a UV heat dissipation and causing more often restart cycles of the FET. Conclusion: the auto-retry feature of the eFuse is valuable, not only for the application requiring a restart after the clear-false events, but also for the applications involving large and extremely large output capacitance which needs to be pre-carried to the target input voltage upon the startup. This method of charging the large output capacitance can be typically faster than just slowing down the output voltage slew rate. Thank you.